Hi, in this screencast, I want to talk to you about how to calculate the percent change. So it turns out that in environmental science, it's very common for us to try to understand how much impact we're having on the natural environment. Yeah, and so as time goes by, some of these changes can seem gradual, but if we do a calculation, we say, oh, we can understand the rate at which we're having an impact, okay? So this could be like how much has the amount of pesticide in the environment changed, how much how much has the population changed, and so on. So the basic equation we use is this. The percent change in whatever variable is equal to the ending value of that variable minus the starting value of that variable, which is just the change in it, divided by the starting value, not divided by the final, divided by the starting value, times 100%. And I forgot to put the percent here, sorry. So this is the equation you need to memorize. We're going to use this a lot this year. A lot, okay? So let's just look at it. Is the percent change is equal to the final value minus the initial value divided by the initial value times 100%. Let's take a look at how this works. Okay, so here's an example. In 1970, the Samson Aquifer contained 350 billion liters of water. And then in 2020, we checked again, we found it only had 200 billion liters of water. So we want to know what the percent change is over that 50-year time interval. So percent change is equal to final minus initial over initial times 100%. So we have is 200, which is our final, minus 350, which was our initial, divided by 350, which was our initial, times 100. I did it again, I'm sorry, times 100%. And we get a percentage change of negative 43%. Now, it's worth noting that anytime our percent change reports a negative value, that means there's been a decrease in the amount of that value. We're subtracting from its overall value. This is called a Keeling curve. It's a pretty important and widely used way of measuring the carbon dioxide of our atmosphere. And so we just want to use this to figure out, well, what is the percent change that occurred from 1965 to 2005 in the carbon dioxide concentration of the atmosphere? So what we do is say, well, in 1965, well, we're going to go to the next slide and it'll be a little bit easy. So what we find is in 1965, we say, oh, we had 320 parts per million in 1965. And by 2005, it looks like we had about 380 parts per million. So percent change is take the final, 380, minus the initial, 320, divided by the initial, 320, times 100, I did it again, 100%. And we now see is the percent change is 18.75%. And it's a positive value, meaning there's been a net increase in that value. All right. Now, one last thing we should point out is that we can use this as a way of making predictions as to what the final or initial value will be. So let's take a look at this one here. So let's just say that I have a forest area that initially occupied an area of 248 hectares, and it experienced a change of so I have this little thing happen here. I don't know why it says that, of negative 38% was the percent change in that land, that forest area. So I want to know what is the new area of the forest. So I'm going to use my equation. Percent change is equal to final minus initial over initial times 100%. I'm going to substitute in the percent change is negative 38%. The initial value is 248 hectares. 248 hectares times 100%. I remember the percent this time. And now I just solve it. So the first thing I'm going to do is going to divide by 100%. So that gives me negative 0.38. Now I'm going to multiply by 248. And I get this. Keep in mind that negative value is going to be very important. And now I'm just going to add this to both sides to isolate the final value. And I see it's 153.76. And I know I did it right because this value is smaller than the starting value. And that makes sense given the fact that I had a negative percent change. All right. Well, thanks for watching. It might seem confusing now, but once you do it a few times, it's going to be easy. When you get on a test, you're like, yay, percent change, I got this one. All right. Thanks. See you next class.